Hey everyone, so this isn't going to be a normal repair video. I actually already got this thing mostly repaired. This is more of, I wanted to talk about the way I did it and how I could have saved myself a ton of time by sticking to the basics and the fundamentals of repairing anything. Now I started making a video about this and I just wound up not recording the rest of, I only recorded the beginning of it. So I'm just going to talk about what I did to get it working and the things that you got to keep in mind whenever you're repairing anything. To start off with, bought this at Goodwill near me, and it says parts only, does not work, 99 cents. Well, that right there, intrigued me. So I opened it up, and you got obviously the calculator. You got a very nice leather case, the instruction manual, and a power adapter. So everything you need. So eventually I got it home, and as you can see when I opened it up, well, there's a 3-cell NiCad pack inside that died a very long time ago, and it leaked acid all over the inside of the calculator. So I removed all the ICs and ran white vinegar over the board just to kind of neutralize the battery acid. And here it is today. I put everything back together even before it moved the screen off. Solder joints don't look great. I understand that. I was still working on it. I got to go back and clean it up. I kind of had things on and off. I couldn't figure out for the life of me, even after I got everything back together, there was a bunch of traces that had been eaten up by the acid, so I had repaired those traces, and as you can see, this board is very, very simple. I'll zoom in. And most of the traces that were eaten were underneath these ICs. I guess that's because that's where it kind of got stuck. And I don't have the microscope on, but underneath where these diodes and resistors are, parts of the board were actually eaten, like a couple of the layers were actually eaten away. But anyway, it could have been a whole lot worse than it actually wound up being. So anyway, got all the traces fixed, got it all back together, turned it on, and still didn't work. And here I'll show you. When you power it up, it just flickers. And when you actually put the keypad on it, the keypad does nothing. It just does this. Okay, so what's the problem? So I was worried about maybe some of these tantalums were bad, so I pulled them out, tested them. They're within spec. They're not great, but they're within spec, good enough. So I'm trying to think, what happened? Why isn't this working? And then it dawned on me, I never did any of the basic troubleshooting, and that is, like with a gasoline engine, you need fuel, ignition, or spark, and air. If you have all three of those, it should run. If it still doesn't run, well, then you got a mechanical problem. But those are the three fundamental things that you need to make a gasoline engine run. With electricity, or with electronics, you're running a DC board, it's got to be A, you got to have power, and B, it's got to be clean power. Never checked any of that. So I tested this. I pulled the... as you can see, it says output 9 volts AC. I tested it with no load. Sure enough, it came out to be about 12 volts. That's perfectly fine. As soon as you put any load on, it's going to come down. So that's fine. And it is an AC output. That AC power brick is literally just, this thing is literally just a transformer. There's nothing else in there, I would imagine. So then I thought, well, you know what? Since the battery is no longer connected, let's just throw 4 volts straight at the board. And voila, as you can see, it turns on, no problem whatsoever. Well, when you first turn on, it does that, and then it clears. And now it works. And I'll show you. With the keypad plugged in, five times 5 equals 25. 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, it works. It absolutely works now. So why does it work off this DC power that's coming off of a bench power supply, but why doesn't it run off the AC power input, or the AC, the AC input? So coming in, you have this power plug. This side here goes down to the ground. The other side runs over here. On the other side of the board, it goes into that diode, just a single diode. I tested the diode works perfect. The output of it comes out, and then it winds up going throughout the rest of it. That's the power supply. That is the input circuitry. That's it. That's all it is. So then I started wondering, well, where's the filter cap? There's some tantalums down here, but they're pretty small tantalums. And for just a single diode, you would need a pretty beefy filter cap to keep that DC even somewhat constant to clean up the input voltage to actually let this thing work. And I mean, you would need a full bridge rectifier for, I would imagine, for this normally, but they just ran a single diode. So essentially what you're getting is, you have to imagine an AC wave, cut that in half, and all you're going to get is essentially pulses of power coming out from the other side of this. So this thing's essentially turning, the reason it doesn't work on the AC adapter is it's turning on and off 60 times a second. Well, how does this work? How did they expect it to work? But then I realized, oh, there's no battery pack connected to this anymore. The battery pack was actually being used as essentially a filter cap. And it was filtering or smoothing the ripple that was coming in, which I thought was interesting. I've never actually seen that done before, but you know, what do I know? That may have been common at one point. I know, like, it's common today. Let's say you have a tablet or a phone and it's dead, and you plug in a USB cable to it. It's not going to boot right away. It's going to wait till the battery has some actual charge, and that's most likely because it requires it can't pull all the current that it needs off the USB connection, unless it's a power delivery, to power the tablet or the phone. So it's going to need assistance from the battery to keep it running, even though the battery is being charged. But in this case, it's actually using the battery more or less to filter or to clean up the input voltage. I just thought that was very interesting. And if I would have, before I started going down the road of testing all these other components and racking my brain, just why is this not working? This should work. The most simplest solution. It was working as intended. I just didn't have that battery pack connected, and that's why. And I should have hooked up DC to it much sooner. I would have saved myself a lot of time. It was still fun to work on, like anything else. You know, it's just, I'm never going to use this. I'll probably wind up selling it. And that's why I want to clean up all these solder joints and kind of clean it up a little bit more and just make it look good. Really, this is just temporary. You know, you throw stuff back together, you just want to see if something works. And I've had all these different components on and off, testing them and checking for shorts, checking for bad. I've been doing continuity tests, just racking my brain. It was the stupidest, simplest thing. It was actually operating the way it was intended. I just didn't have the battery pack connected, and that was the battery pack was the smoothing cap. Anyways, I know this is kind of a weird video to do, but I just wanted to put it out there that, you know, if you're working on something and you're just racking your brain, can't figure it out, sometimes take a step away and say, okay, what am I forgetting? What are the basics? Does it have power? Does it have clean power? Does it have the basic necessities that it needs to make this circuit operate properly? And that's where I screwed up. I should have done that, but I think we all do that occasionally. You just get ahead of yourself. You see all the damage done, you clean it up, and you think, well, it could be something else, could be something more. When no, it actually, you fixed everything. It was just just the way it was built. So anyway, that's that. Sorry, I hope didn't ramble too much. I hope I made my rambling made some kind of sense. And I'm gonna get this thing cleaned up. I gotta find some NiCads. Build a new battery pack for it and stick it inside, and then I'll probably wind up selling it because I just don't have really a use for this thing. I like old calculators. I think they're kind of cool, but I just, when the hell do I ever use it? So that's that. So I hope everybody's having a good one, and I will hopefully see you next time. All right, bye-bye.